All right, I'm Dion Davis for Purdue Ri3D, and this is our shooter prototype. So one of the most important things for this was actually not the wheels. Using these 3D prints really helped us prototype fast for proper spacing between these wheels, and then also using lots of 3D printed spacers expedited our construction process, which got us moving faster. But a couple of key components like specs of our shooter is this gear ratio here. It's a 2-to-1. We're using a 40 tooth gear driving a 20 tooth gear. They're metal, and then that's on a max length hex half-inch hex shaft with a couple of different durometers, so that while testing we can use the gray Andy Mark wheels, orange, blue, and then green. One thing I also need to go over is our squish or compression over it. So I'm not exactly sure on what our compression on the ball is, but I can tell you that we are using 4-inch diameter wheels on the top and bottom, and we have roughly a 9-inch center to center distance on here, so that the squish of the ball is not a ton, but just enough for the ball to have enough grip on the wheel to actually transfer from whatever our indexer is to the shooter and then launch it out.
You shoot to like see how hard it is.
And these, like they showed in the video, are rather firm, so definitely not like the smaller yellow balls before. They're a really dense foam, really bouncy, and way less compliant than a lot of balls in previous years. If I had to do a rough estimate, I would say the tennis balls from Rapid React with proper inflation are a pretty similar ball compliance here. So having a little bit of a looser compliance here is a pretty good thing, because the ball is not going to squish for you, and that also then gives you a little bit of a more accurate shot if you have less squish in the ball. So real quick, 2 inches 9. We are doing about a 1-inch compression on the ball at the wheels, but keep in mind the shafts flex a little bit, so there's a little bit of compliance from us there, and then a little bit of squish in the balls, but from surface to surface of the wheels, it is 5-inch compression for a 6-inch ball. One thing to note, which some people probably have already seen, is these bars are rather long, and an issue we ran into with testing was it actually wiggling a little bit because it's unsupported in the middle. So if you do end up going with a large wide intake like this, you will want to have a crossbar like this closer over top the wheels so that you can support it in the middle, so you have a little bit of less flexure. But ultimately, if you could come out here a little bit through shooting, you can see gray, orange, blue, and green. For our test, the gray seemed to have the best pattern and best spread for the balls. It was the most predictable, most close together. But once again, the orange and the blue were in that middle of the flexure of the bars. We're gonna fix that on our final, but ultimately, gray seemed to be pretty tight, and then green also was rather tight, partially because they were towards the ends, once again, that flexure. But we did have one outlier with the green, which shot it all the way over here at about 36 feet away from our shooter, which was an odd outlier, so we wouldn't rely on it, but it's definitely possible to get accurate and far shots. As you can see here, green definitely shot the furthest, and that's mostly due to the grip that the green wheels have. Their durometer is the squishiest, the rubberiest, the grippiest, especially on these denser and rather slick balls in comparison to the other durometers. And I'm not sure if I went over this already, but our motors are running at max speed, 12 volts. I believe with the ratio and 12 volts, that's roughly 15,000 RPM at the shaft. And we are actually using a top and bottom roller. So on this side, if you'll come around, there is a X44 on each of the shafts here, So there's one for the top and one for the bottom. And this is so that when we end up doing our final robot, we can shoot from anywhere on the field, hypothetically, by varying how fast the top roller is spinning and how fast the bottom one is, to kind of adjust the arc to get a better approximation of where we want it to land. And once again, I'm Dion Davis, and I think that's all we have for our shooter today.